Picture this. It's 11 p.m. on a Tuesday. A developer on your team has been working late trying to fix a bug that's been annoying customers for 2 weeks. They finally crack it, type git push origin main, and head to bed feeling good. By midnight, the support Slack channel is on fire. The production API is returning 500 errors to every user. The fix introduced a broken import. The tests would have caught it in 30 seconds. But the tests never ran. No branch protection. No required CI check. No reviewer. Just a direct push straight to main, straight to production, straight to an incident page. This story plays out every single week at engineering teams that haven't configured branch protection. This chapter is about making sure it never happens to yours. Branch protection rules are repository settings that enforce a gate in front of your most important branches. You configure them once under settings, then GitHub enforces them automatically for every developer, including repo owners and organization admins. The core idea is simple: before any code can land on a protected branch, certain conditions must be true. Maybe the CI workflow must have passed. Maybe a human must have approved the change. Maybe the branch must be fully up to date with the base. You define the conditions, and GitHub handles the enforcement. The developer experience is completely automated, no need for anyone to manually check before each merge. The gate opens when the conditions are met and stays closed until they are. Branch protection has many options, but 2 settings deliver most of the safety any team needs. First, require status checks to pass before merging. This is where your GitHub Actions CI workflow connects to branch protection. If the tests fail, if the lint fails, if any required job fails, the merge button stays grayed out. The machine has spoken. Second, require pull request reviews before merging. This adds a human in the loop. At least one teammate must read the code and click approve. The machine checks that the code works correctly. The human checks that the code does the right thing. Together, these 2 protections catch an enormous percentage of production incidents before they happen. You'd be surprised how many outages can be traced back to the absence of one or both of these settings. The integration between GitHub Actions and branch protection is seamless once you understand the flow. A developer opens a pull request. GitHub detects the PR and fires your CI workflow automatically because you configured the pull_request trigger in your workflow file. The workflow runs your tests, your lint, your build, everything in the job. When the job finishes, GitHub Actions posts the result back to the PR as a status check, a named pass or fail signal attached to that specific commit. Branch protection then reads that status check. If it's green and all other conditions are satisfied, the merge button activates. If it's red, the merge button stays locked. This entire cycle is automated. The developer pushes code, waits a few minutes, and sees either a green light or a list of what they need to fix. No human needs to manually gate anything. Once branch protection is in place, every pull request becomes a live dashboard of code quality signals. Scroll to the bottom of any PR and you'll see the checks panel, a list of every status check that branch protection requires, each one showing its current state. When a PR is fresh, the checks show as pending with a spinning indicator. As the CI workflow progresses, they update in real time. When everything passes, each check gets a green checkmark, and if review requirements are also satisfied, the merge pull request button turns green and becomes clickable. When something fails, you see red X icons with a details link that jumps directly to the failed job logs. The merge button stays grayed out with a clear message explaining what's blocking it. This transparency is one of the most valuable things branch protection gives your team. Reviewers can immediately see the health of a PR without running anything locally. Let's walk through setting this up. Open your GitHub repository and click the Settings tab. In the left sidebar, find the Code and Automation section and click Branches. You'll see a Branch Protection Rules section. Click Add Branch Protection Rule. The first thing you configure is the branch name pattern. This is a glob pattern that tells GitHub which branches this rule applies to. Type main to protect exactly the main branch. Or use release/* to protect every branch whose name starts with release. The pattern supports wildcards just like the trigger filters you learned in earlier chapters. You don't need to create rules for every branch individually, one pattern can cover a whole family of branches at once. Note that you'll need admin access to the repository to create or modify branch protection rules. If you don't see the Settings tab, check with your repository owner. With your branch pattern set to main, scroll down to the Protect Matching Branches section and check the box that says Require Status Checks to Pass Before Merging. A search box appears below it. This is where you connect your specific workflow job. Type the name of your CI job exactly as it appears under the jobs key in your YAML file. If your workflow defines a job called CI, type CI into the search box. GitHub will surface the matching job name in a dropdown. Click it to add it as a required check. You can add multiple jobs here. For example, you might require both a test job and a lint job to pass. One important constraint: the job must have run at least once on the repository before it appears in the search results. If you've never pushed the workflow before, run it once manually or push a test commit first, then come back to configure the required check. There's a subtle but important option just below the status check setting: require branches to be up to date before merging. This one is easy to overlook, but it prevents a class of bug that haunts teams who don't know about it. Here's the scenario. PRA and PRB both pass CI independently. But PRA adds a new function that depends on a utility file that PRB quietly deletes. Neither PR has a failing test on its own. The problem only appears when both changes coexist on main. Without the up-to-date requirement, both PRs can merge in sequence, and main breaks. With it enabled, after PRB merges, PRA can no longer merge until the developer clicks Update Branch, which pulls in the latest main, including PRBS deletion, and reruns CI against the combined code. The conflict surfaces before it reaches main, not after. Enable this option. The small slowdown for developers is absolutely worth the protection it provides. Scroll further to find Require pull request reviews before merging. Check this box. Set the required number of approvals. Start with 1 for most teams. 2 is appropriate for security-critical or high-risk code paths. The setting that most teams miss immediately below is dismiss stale pull request approvals when new commits are pushed. Always enable this. Here's why it matters. A reviewer looks at a PR, sees it looks good, and clicks approve. 2 hours later, the developer pushes a new commit that contains a completely different change, maybe an experiment they forgot to clean up. Without dismiss stale, the PR still shows as approved. It can merge with code the reviewer never saw. With dismiss stale enabled, GitHub automatically removes the approval the moment a new commit lands. The developer has to request a fresh review. The reviewer sees the updated code. This is how code review should actually work, and it's a one checkbox difference. Once you require pull request reviews, you face a new question: who gets assigned to review what? In a large codebase, you can't rely on developers remembering to tag the right team. The .github/CodeOwners file solves this automatically. The file uses a simple pattern-to-owner mapping. Each line is a glob pattern matching file paths, followed by one or more GitHub usernames or team references. When a PR changes a file matching a pattern, GitHub automatically adds the listed owners as requested reviewers. The file is evaluated from bottom to top, so place more specific patterns lower in the file to override broader patterns above. You can protect your workflow files by assigning them to a platform team, route front-end changes to the UI team, and ensure every infrastructure file gets reviewed by the infra team, all without anyone having to remember to tag anyone. Pair code owners with the Require Review from Code Owners branch protection option, and code owner reviews become mandatory, not just suggestions. The best way to verify your branch protection setup works is to deliberately break it. Create a branch, write a test that intentionally fails, and open a pull request. Within a minute or two, the CI workflow will trigger, the test job will fail, and the PR status panel will show a red X next to your required check. Scroll to the bottom of the PR. Instead of a green merge button, you'll see a grayed out button and a message: merging is blocked. The base branch requires all status checks to pass before merging. There's a details link that takes you directly to the job log showing the failure. Now push a fix. The CI workflow triggers again. This time the tests pass. The status check updates to green. If you've also configured a required review and you have an approval, the merge button activates automatically. This is your CI pipeline and branch protection working exactly as designed: automated enforcement that removes the possibility of human error in the merge decision. Classic branch protection rules work well, but they have limitations. Each rule applies to exactly one branch pattern, they can only be set by repository admins, and they offer no way to grant limited bypass access without making someone a full admin. GitHub's newer rulesets system addresses all of these gaps. A single rule set can target multiple branch name patterns, apply at the organization level to protect branches across hundreds of repositories at once, and define bypass actors: specific GitHub users, teams, or apps that are permitted to bypass the ruleset's restrictions under defined conditions. This bypass actor concept is valuable for operational scenarios like emergency hotfixes or deployment bots that need to merge without going through the normal flow. The bypass is explicit, named, and fully auditable in the push history. You'll find rulesets under Settings, then Rules, then Rulesets. They can coexist with classic branch protection rules, so you can migrate gradually without disrupting existing setups. For teams in regulated industries or those with strong audit requirements, standard branch protection often isn't enough. 2 additional settings raise the bar significantly. Require linear history prevents merge commits from landing on the protected branch. Every PR must be merged using squash merge or rebase merge, producing a flat, linear Git log where every commit on main maps to exactly one pull request. This makes Git bisect dramatically more useful for tracking down regressions and gives you a clean audit trail. Require signed commits goes further. Every commit must carry a valid GPG or SSH cryptographic signature. GitHub displays a green verified badge on signed commits. Without a valid signature, the push is rejected. This prevents commit author spoofing. An attacker who gains brief access to a repository can't quietly inject commits pretending to be a legitimate team member. Both settings come with real operational overhead. Developers must configure signing in their Git client, and every merge strategy choice must be enforced consistently. But for teams that need them, they provide meaningful protection. Here's a gotcha that has locked PRs and frustrated teams at organizations that didn't know about it. When you add a CI job as a required status check in branch protection, GitHub stores the job name as a string. It then waits for a status check with that exact name to appear on each commit. If you later rename the job in your workflow YAML, say, from CI to test suite, GitHub's branch protection still expects a check named CI. But your workflow now produces a check named test suite. The required check shows as expected waiting on every new PR, indefinitely, because the check it's expecting never arrives. The merge button is locked. No commits from that PR will ever satisfy the requirement automatically. An admin must go into branch protection settings, remove the stale CI check, search for and add the new test suite check, and save. The fix is instant once you know what to do, but diagnosing it the first time can be deeply confusing. The prevention is simple: keep required job names stable, use lowercase, keep them short, and always update the branch protection rule before or simultaneously with any job rename. Final question for this module. A developer runs git push origin main, pushing directly to the protected branch, bypassing the PR process entirely. No CI ran, no reviewer saw the code. Which branch protection setting specifically prevents this? The answer is the direct push restriction. Do not allow bypassing the above settings, combined with restrict who can push to matching branches. Status checks and review requirements only apply within the PR flow. They have no effect on a direct push because there's no PR for them to evaluate. The setting that blocks the act of pushing directly is the push restriction. With it enabled, only designated users, teams, or apps can push directly to main. Everyone else must go through a pull request. This closes the last obvious hole in your protection setup. With status checks, PR reviews, and push restrictions all enabled, your main branch is locked down. Code must be reviewed by a human, tested by your CI pipeline, and merged through a pull request. That's the full story of branch protection. Module 3 is complete. Up next, continuous deployment.